All right, welcome everybody to East Coast weather flying during the warm season. A lot to cover in this short 1-hour presentation, so we'll dive right in. And my name is Scott Dennstaedt. I'm a CFI and former National Weather Service meteorologist. I'm also founder of EZWxBrief, EZWxBrief.com. And I'm the co-author of Pilot Weather from Solo to the Airlines, co-authored with Doug Morris, who is a Boeing 787 captain for Air Canada. And coming really soon, the end of July, just in time for AirVenture, I have a new book that's going to be coming out called The Skew T, Log P, and Me, a primer for pilots. It's going to be an ebook format only, and I'll tell you more about that at the end. And I'll also do a daily easy weather brief at 7:20 a.m. Eastern time every weekday morning on YouTube Live. Kind of covers the weather across the United States. So if you're flying or you want to learn a little bit more about weather, it's about a 15-minute program every single weekday morning, and at my YouTube channel, AVWX Workshop. So go ahead and take some time and subscribe to that. You don't have to watch it every day, of course, but ultimately, I think you'll learn a lot. All right, so here's today's topics. And some of these topics you might not think you were expecting to learn about, but I really want to kind of take a step backwards, explain a lot of the big weather picture stuff that's going on. It's really important to understand that before we kind of dig into the specifics of flying on the East Coast in terms of summertime weather. So we'll talk about upper level flow patterns, this concept of pulse type thunderstorms. We'll look at the expectation of landfalling tropical systems, and we'll cover turbulence, wind, and mountain waves in terms of what to expect there as well during this time. And I hope to be able to give a route planning example in real time using real weather so you can see how to put it all together. And if there is time at the end, hopefully there'll be a few minutes at the end, we can go through some Q&A. All right, so this is where we're going to be focused here. Basically, starting up in Maine and working our way all the way down to Key West, Florida. Essentially, this is the location that we're kind of focused on, all the way from the Appalachian Mountains all the way over to the coastal plains is kind of where we're kind of thinking. Now, you may be flying up and down this coast all the time, or you may be from the Midwest looking to fly east. That's fine as well. I lived in Baltimore and now I live in Charlotte, so I've gone up and down the East Coast many times. So this is kind of the focal point for today's webinar. So first of all, let's talk about upper level flow patterns. So there are two primary jet streams in each hemisphere. There's the polar jet and what's called the subtropical jet stream. It's important to understand how these come into play depending on what season you're talking about. We're going to be talking about summertime weather, so basically from the end of June all the way through early September, and kind of what to expect there. But when we look at the big picture in the North American area, this is what we're kind of looking at from that big picture perspective. So these jet streams have two primary flow patterns. And that is, the first one is meridional flow, and the second one we call zonal flow. Now, I'm going to focus mainly on talking about zonal flow in this particular webinar because that's really the dominant thing that we'll see during the summertime weather. But let's talk about both of those for now. And so essentially, when you think about meridional flow, the word meridian, essentially like the prime meridian, is lines of longitude. So when we're talking about a meridional flow pattern, we're talking one that has a lot of north and south kind of flow to it. In this particular case, this is a very high amplitude pattern here in the jet stream. And so we call that, again, meridional flow. And that's usually dominant during the late fall, wintertime, and early spring. The other possible pattern is what we call zonal flow. It's a more flat pattern. It doesn't have a lot of waves to it. And generally speaking, it's west to east kind of flow. I know you're taught that most of our weather systems tend to go from west to east, but and that's true in the case of zonal flow patterns. But in the meridional flow, some of our weather comes out of Canada from north to south and then moves all the way up from south to north. In this particular case, zonal flow pattern is really just a west to east kind of a flow. So during the early summer, usually around the beginning to middle of June, the polar jet stream takes a vacation and migrates into Canada. So it moves further north as the area in the tropics becomes warmer, and therefore the jet stream, the polar jet, tends to move up further north. And that kind of polar jet tends to have a lot of meridional or north to south flow. It tends to be very wavy. But during the summertime, it ends up more closer to the north of the U.S. and Canadian border, although it can peak down occasionally from time to time into the conterminous U.S., but the primary flow pattern is up into Canada during the summertime. The subtropical jet that you see there in orange will also eventually migrate further to the north. And that flow is often very zonal pattern. So in the case of the subtropical jet, in the summertime is really where we spend most of the activity happens to be in that kind of a jet. So, and again, it's often zonal, and it's not as intense as the polar jet. So it's pretty easy sometimes to see even up in the higher flight levels where you might have winds aloft only 20 to 30 knots in worst case scenarios. So it tends to be a lot less aggressive in terms of wind speed. So when we look at a jet stream itself, and it doesn't matter really what altitude you're looking at here, normally I reference around 18,000 feet or 500 millibars. What we have to understand is how Mother Nature works. So Mother Nature abhors extremes. So anytime there's an imbalance in the atmosphere, Mother Nature tries to bring things back to an equilibrium. And we do know that in the polar regions, there's cold air in the polar regions and warm air in the tropics, and that produces an imbalance. And so in order to correct that imbalance and bring things back to a more equilibrium, Mother Nature pulls cold air down, and we call that a trough. That's that U-shaped feature in the jet stream. And then to pull warm air up from the tropics in the form of a ridge. So this is the pattern, the meridional pattern that we're speaking about. Now, as this all migrates up, basically we're just dealing with warm air from west to east in more of a zonal pattern. And so if you're looking at a meridional kind of pattern like this is what we typically see. So here's our trough in the western U.S. here. You can see it kind of being a very meridional, kind of north to south, south to north kind of flow here. Usually the worst place to be in a trough is kind of downwind of that trough axis. So essentially we'll see unsettled or deteriorating weather in that region. And it generally is fair or improving weather upstream. And so that's what we generally expect under meridional flow. And in zonal flow pattern, all that again is up further north into Canada. So this is what a zonal flow pattern might look like. So we have, here's the United States down here, and we generally have a kind of a west to east flow. Yes, there's a little bit of waves to it, and it's not uncommon to see that in the Pacific Northwest or even in the area in the Northeast U.S., but for the most part, most of the country ends up having this general west to east kind of a flow. And this is being shown at 500 millibars, which is roughly 18,000 feet. So half of the mass of the atmosphere is above 500 and half of the mass is below. And I call that the belly button or waistline of the atmosphere because essentially that's the area that we want to watch in terms of where the most significant energy is, or upper level disturbances in the atmosphere. And so we'll look at that when we do our flight planning session at the very end. So again, here's a very kind of aggressive, more aggressive zonal flow pattern. We can see this happening even in the wintertime in some cases, but ultimately one of the things that's kind of a mark for a zonal flow pattern is we tend to see what are called mesoscale convective systems. They really love this kind of zonal flow pattern in the United States. And I'll just say that most of these mesoscale convective systems are somewhere between the Rockies and east of the Rockies and west of the Appalachians. Occasionally they do make it over the Appalachians and become problematic. In fact, there's an anniversary for a derecho that came through the DC area about 10 years ago today, or tomorrow, that is. And so ultimately it can become a significant storm in the east, but this is a kind of a Midwest or even a plain state kind of a system, but it loves zonal flow patterns for that situation. All right, so now let's talk about this concept of pulse-type thunderstorms, because that's the thunderstorms that we're going to mostly see during the summer months. So let's first of all kind of categorize the different kinds of convection. I know most folks think about all convection is the same, but it's really not. First of all, there's frontal convection. So there's a strong cold front or even a weak warm front moving through, and we see thunderstorms or convection ahead of that cold front or along the warm front. Then there's that mesoscale convective system, kind of a weird beast into itself. Again, it's mostly a May through October kind of time frame where we see these. And again, they tend to be between the Rockies and the Appalachian Mountains. But that's one element that we'll see in terms of organization of convection. Then there's tropical convection, tropical storms and hurricanes and such. And there's these pulse-type thunderstorms as well. So the last two here is what I'm going to focus on here, because that's really what's going to affect us if we're flying up and down the East Coast during the summertime. So pulse-type thunderstorms really develop in regions where there's really no important change of air mass. The atmosphere is fairly unstable. So there's no frontal systems to speak of, or maybe there's a weak frontal system in the area. Maybe it's dissipating, so to speak, but it's not necessarily an important change of air masses like we see during the fall, spring, and as well as over throughout the winter as well. So they look like, just like you see here, they tend to stand out. They're easy to spot. You may also have heard the term pop-up thunderstorms, and anybody who knows me knows I hate that term because they just don't pop up for whatever reason. They tend to develop for some reason, although it may be hard to really figure out why they are existing at a specific place and time. But you may also have heard of them as called air mass thunderstorms as well. So they're all the same thing, but meteorologists like to call them pulse-type thunderstorms or pulse-type convection. And they're very easy to spot. They sit out there like a sore thumb, and ultimately we can navigate around those fairly easily. They tend to be very common in this zonal flow pattern. That's why I mentioned this. When you look at these, again, they're not necessarily going to be associated with frontal systems. That's a whole different kind of convection, but they do tend to be very likely in a zonal flow type of pattern. They're diurnal, which means they occur typically in the afternoon kind of hours or early evening. And so you get a good heating of the day, and sometimes you can get a new round of pulse-type thunderstorms going just because of that. There may be some outflow boundaries from other thunderstorms from the previous day that help kind of trigger that, or there may be a sea breeze that may occur as well. They tend to have very little vertical tilt with height. You can see this is pretty much just a core element here, and it's very straight up and down. There's no tilt to it, whereas some of the really strong severe storms that you'll see in the Midwest or in the plains, where you'll see severe thunderstorms. Those will have a significant amount of tilt to them, and they're rarely embedded. Normally, again, they're easy to spot. Like you can see here, I was at 15,000 feet, headed back into Charlotte from down in the Georgia area, and you could see these lined up, a couple of those up there. Very easy to spot, easy to work your way around. They're not usually severe. Sometimes you can get some really strong wind gusts out of these. They do develop very rapidly. Usually there's a lot of fuel for the thunderstorms in terms of moisture, in terms of the ability for instability to get those going. So they tend to develop from that cumuliform type all the way into a mature thunderstorm pretty quickly. But because of their vertical structure to them, they tend to rain themselves out within, basically rains right through its own updraft, and they can rain themselves out within an hour or so. They don't usually last very long. So if we look at the climatology, again, you probably weren't thinking about, you're going to learn a bit about climatology tonight, but ultimately it's important to understand this, because when we're making decisions to fly, it's really important for us to time things well. I know most pilots are told fly early morning if you can, because you're going to beat the thunderstorms. That works. In fact, it works really well in the summertime along the eastern seaboard, but it may not work very well in other places in the country. So you can see here, this is called the convective sigmet climatology. The left is 11 to 13Z, so early morning, 14 to 16Z, so more late morning, early afternoon, 20 to 22Z, and then you finally get to the more late afternoon, early evening. So anywhere you see red here, there's a lot more higher frequency of convective sigmets issued. That means there's convection. It meets certain criteria. And the blues or the whites are areas where there's less in that sense. So look here in the morning, all along the East Coast, we don't see much in the way of any significant thunderstorms that meet convective sigmet criteria. Most of those actually occur along in the water, and that's because in some cases the water is actually warmer than the land in the overnight hours, and that's where you get all the instability. So the water itself is essentially driving a lot of those convective sigmets in those areas. But once you get into the afternoon, it really heats up here. No matter where you are along the East Coast, just about, you're going to get the possibility of some thunderstorms that meet convective sigmet criteria, or if you're here out west, the monsoonal season really kicks in at that particular point in time. But I want you to quickly notice this while I have this up here, is that here's the early morning hours. Again, most of this is driven by those mesoscale convective systems, which tend to be nocturnal beasts. They tend to develop late or early evening into the later evening, and they persist into the overnight hours, into the early morning hours. So in that part of the world, not a good idea necessarily to get up in the morning and try to beat the convection out. And you may be staring at one of those mesoscale convective systems in the early morning hours. So again, some of these pulse thunderstorms just don't tend to meet convective sigmet criteria in some cases. So they may be too isolated. They may not necessarily be organized in any way, so they may not reach the criteria that is used for convective sigmets. So in some cases, you may not even have any kind of advisory for convection. Here's a great example that I was making a flight up from Charlotte all the way up through to Baltimore in this particular day, and pulled out, this was the old Barron's XM weather. Took a snapshot of that before I left. And you can see there's definitely some convection here all along this route essentially from my entire route just about. But, Charlotte Douglas Airport didn't have any kind of forecast for any kind of convection. Florence didn't have anything. Raleigh-Durham didn't have anything. Greensboro didn't have anything. Columbia didn't have anything. There was no actual forecast for thunderstorms in that particular case. But as you can imagine, I had to dodge a lot of convection, but because it didn't meet convective sigmet criteria, and because these are very highly scattered, you have to remember that terminal area is really small. That little dot here and green dot here you see near Charlotte that's about the size of the terminal area. In fact, it's probably a little bit smaller than that. And so when you're looking at it from a standpoint of the forecaster, they're looking at that small area going, no, this is too widely scattered for me to put any kind of forecast for thunderstorms. So what a lot of times they'll do is they'll add VCSH or SHRA to quantify that uncertainty. We know VCSH stands for showers in the vicinity, and then we have SHRA, which stands for showers, rain showers in the terminal area itself. And so they'll add that to the TAF sometimes and not add any TS or TSRA because of the uncertainty that they have right now. But we know that showery precip is a convective process. So it's really, they're hinting to you, be careful, there could be some thunderstorms in the area. Right now, we're not sure of that, so we're going to put this particular placeholder in there for it. So it's a good idea to read over the area forecast discussion. This is available, a lot of the heavyweight apps out there provide it. EZWxBrief, we provide it as well. It's written by the same forecasters who issue the TAFs. Really good idea to read this if you're flying anywhere along the coastal regions or anywhere in the eastern third of the country. And this allows them to kind of quantify, kind of talk about their uncertainty in the discussion. Some forecasters do a really good job and some do a mediocre job at that. But for instance, you may have something like this. So Charlotte Douglas or whatever may put in showers in the vicinity here in this particular case. But read through it. Scattered showers and perhaps a thunderstorm are expected across the Piedmont, North Carolina Piedmont, from the afternoon into early evening, and will carry VCSH for now to cover that threat. So that's what they're telling you, that they can't put thunderstorms in here, but they're putting that showers in the vicinity to kind of give you that indication that there is the possibility. And as thunderstorms do develop and move towards the terminal area, a lot of times they'll amend the TAF and take out VCSH and put in TSRA. That's how it kind of works. All right, so when you're looking on the charts here for the various different things in terms of convection, it's not unusual in the prog charts to see this kind of really large light green area. And that basically is telling you you've got the possibility with the slashes here of being the possibility of convection in that region. It's very common to see that during a lot of the summertime months. There's not any, this is kind of that scattered and isolated kind of convection that's going on. It could be even as low as a 15% chance in this region. I've flown through a lot of these green areas and barely saw a cloud, much less any kind of precipitation. But it could be as much as 55% chance. So it's not until you get to the dark green areas where it's 55% chance or greater. All right, let's switch to talking about landfalling tropical systems. Now, right now, there are no tropical systems to worry about here along the East Coast. There is one that's kind of creeping into Louisiana, into Texas. It hasn't been a named storm yet, but it's certainly kicking up a lot of dust there. Hurricane season started on June 1st and goes all the way through November 30th. And essentially, anytime you get a zonal flow pattern, that tends to be really supportive and favorable for the development of tropical systems. As you can see here, this is the ultimate of spaghetti diagrams. You can see there's lots and lots of tracks that take those tropical systems up into the U.S. But I want to make very clear that the tropical storms, this is not your ordinary convection, essentially. Once those systems make landfall, those remnants, the leftovers, once it makes, it has moved inland, have a tremendous amount of shear associated with them. And yes, nobody is going to fly into the center of one of these unless they're paid to do it through the hurricane hunters. But ultimately, when this thing hits the coastal regions and makes landfall, be very wary of all those precipitation bands. They may not have an extremely interesting signature like you're used to seeing with some of the frontal convection or even the pulse type thunderstorms, but they have a lot of shear in them. And so essentially, when you're looking at this, you're also looking at the fact that when that system ends up making landfall, like in this particular case here, it will potentially hold on to a lot of its tropical characteristics, and due to its nature, will have very minimal lightning associated with it. So if you're really, depending on your storm scope or your SiriusXM lightning, be very careful about that because you may not see much in the way of lightning as it starts to make its way wherever it happens to track throughout the eastern United States. In fact, here's a case where Hurricane Katrina had made landfall and made it up towards kind of the spine of the Appalachians here. And notice here's 2 tornado watches out for that particular area. And all these pluses and minuses are lightning strikes over a 15-minute period. Notice not much in the way of significant lightning in that area, but there were plenty of tornadoes that occurred during that particular time frame. So again, these systems need to be watched very carefully after they make landfall. All right, let's briefly talk about turbulence, wind, and mountain waves. Well, first of all, there's 2 different kinds of convection. One is dry convection. That's that convection that we hate, we have to endure, we hate it, we get bumped around a couple thousand feet above the ground in thermal turbulence. It's just the nature of summertime or that high insulation kind of a day. And there's also moist convection. That's that cumuliform clouds that develop into eventually towering cumulus and into cumulonimbus clouds as well. So most of the convection you're going to see during the summer months is going to be in the area of dry and moist convection. There's very little clear air turbulence. Yes, you might get some of it up here further north, but when you start getting above the Mason-Dixon line and further to the south, you rarely see any kind of clear air turbulence kind of advisories. It's just because most of it is convective, and the GAIR mets for turbulence are all for non-convective kind of clear air turbulence going on. Winds are generally light overall. You may get some stronger winds up further north. Certainly any higher elevation to airports might be problematic, and also some of the coastal regions can be pretty windy at times due to the sea breeze that's occurring there as well. But overall, winds are just generally fairly light, so usually you don't have to worry about these strong crosswind kind of things going on along the eastern seaboard. And given the fact that the winds aloft are really minimal, and in most cases the atmosphere is unstable during the summertime months, mountain waves really require stable air above the ridgeline in order to get a good mountain wave going, and we generally don't have that. So if you see over the top of the Appalachians a bunch of cumuliform clouds, those white puffy cauliflower-like looking clouds and building up, that tells you that mountain wave activity is just not going to happen, just because you've got unstable air above the ridge lines, not stable air. All right, so here we go with a route planning example. Usually pretty difficult to, hopefully it won't go too bad here when we go through live weather. We'll see what happens here. So we're going to do a trip that's from Albany, New York. We're going to go down through Martinsburg, West Virginia, then down to St. Simon's Island down here in Georgia. And we're going to depart at 7 a.m. And we may need, depending on the aircraft you're flying, may need actually a fuel stop somewhere along the way. But the goal is to kind of get out early in the morning. You already said Scott tells us that you got to get out early in the morning. We're going to try to make this trip in one day, although that may not necessarily happen. So we're going to plan to depart at 7 a.m. tomorrow morning and see how that works. So let's see if we can make this work here and take a peek at things. So this is the national forecast chart. I like to look at this as kind of the big weather picture. So let's look at tomorrow's forecast here. Nothing really major here. There's no major fronts that are associated with this. So this is a very typical kind of summertime day in the southeast U.S. and even up into the mid-Atlantic. The thing about East Coast flying, and sometimes the southeast can be really bad and mid-Atlantic and northeast can be fine, and sometimes it can reverse depending on the situation. So ultimately we have kind of a big area of high pressure throughout the mid-Atlantic all the way over into the Tennessee Valley and even into the central and southern plains for today, or for tomorrow. And we do have a little bit of a frontal system sagging down here into the northeast. It tends to be, looks like it's pretty dry, not a lot of precipitation being shown here. And the primary area weather here is those rain and thunderstorms that you see down at the bottom all through the southeast U.S. So again, this area here is where we're trying to get to. So that may be problematic throughout the day. So maybe the first leg is good. Maybe we'll make sure our fuel stop is before all this so we can land, check the weather again, and identify what's going on. So this gives us the first big weather picture view. What I like to do next, and I do this with every one of my flights, is I look at that 500 millibar chart. Again, we want to characterize the big picture weather, what's happening here. So when we look at this, what we see here is we have our high, a ridge out off of the coast here, but for the most part, this entire area here, you can see just a slight ridge going through all this area here. That's bringing that warm air up, whereas we see the main flow here is way up here. That's the more wavy flow. But in generally speaking, we have, for the most part, kind of zonal pattern all the way through here, and even very light winds up at 18,000 feet further south. So that's kind of, it gives us a kind of very good indication of the simple fact is we have that zonal flow pattern with a little bit of a trough pattern up to the north. But and now we watch what's happening kind of with that pattern overall, and see that that upper level trough is moving off to the east. So there's our upper level trough here. I'll zoom in on this. There's Maine up here to the north, and that entire trough pattern is essentially moved off the coastline. And so therefore, it's not going to be problematic for us. What we do have is essentially that zonal pattern, that west to east flow, and very, very weak flow elsewhere. Now, there's this other colored area here. I'm just going to mention that's called vorticity. Sometimes you can see vorticity. Here's that tropical system I mentioned that was kind of trying to take shape here along the Texas area. It's kicking up against some dust, but ultimately, for the most part, most of the convection that's going to occur here is not really associated with any kind of major fronts or anything. This is all basically going to be those diurnal afternoon kind of thunderstorms, and mainly those pulse type thunderstorms or pulse type convection going on in that area. So the first part of the routes from Albany down to Martinsburg, all the way down to maybe some parts of North Carolina, should be pretty good. No major problems there. And so we look at the prog charts, again, see if what's going on here. And there is a little, looks like a frontal system kind of draped here. It's not unusual to see this again. We get cold air kind of trying to make its way down because of the subtropical ridge that's occurring in this area, that ridge of high pressure. It eventually just can't make it very far south. And it kind of stops here at this point in time. And what we end up with is, kind of this isolated afternoon kind of thunderstorm kind of pattern here. So if we move this over till tomorrow morning, the good news is that a lot of this does kind of fade away, at least in the early morning hours, but along the coastal regions is where we're going to see it. And of course, we're going down to St. Simon's Island off the coast of Georgia. So therefore, that's the area that we're kind of seeing even in the morning hours. But for the most part, most of this frontal system up here in the Northeast, in mid-Atlantic down here is pretty dry, nothing going on there because it's on the backside of that trough, and therefore kind of the improving weather that we saw on one of those charts earlier, where we see improving weather on the backside of those trough. Now this will switch to 18Z, and now things kind of start to heat up. Now we're kind of seeing that even there's a little area here, even in Virginia into southern Maryland, that might kind of creep into the picture, but the majority of the concern is really in the southeast U.S. as you get into North Carolina and finally into South Carolina, down to Georgia. And even you got a couple of areas here where you got dark green, so that's a 55% or greater chance of having that at 18Z. So we definitely want to be on the ground before all this kind of takes shape. Now, that's a 12-hour, it's a 6-hour kind of jump from 12 to 18Z. I like to use a couple of other products that are in my imagery here, and let's go ahead and look at those. First of all, let's just look at, again, the big weather picture, convective outlooks from that standpoint. For tomorrow, let's move this over till tomorrow's convective outlook here. So this is the valid for Thursday, and it's pretty much all day on Thursday from 12Z to 12Z. So it starts at 12Z in the morning till 12Z the next day. So all the white areas, there's really no organized areas of thunderstorms. And in the southeast, there isn't any kind of organized severe thunderstorms. These are just general thunderstorms, again, most likely to be generating pulse-type thunderstorms in that area. If we then kind of look at the ECOTOPS forecast, and I'll explain this. This is one of my favorite products to look at. Essentially what this tells us, let me roll this over until we get to like 11Z tomorrow. So this is a probabilistic forecast. So you see that the colors here are probabilities, and it basically tells you and says, what is the probability that the precipitation core reaches the level up to 30,000 feet or greater. And we know that if the top of that precipitation core is at 30,000 feet or greater, and there's a high chance of that, that's deep convection. That's something we want to avoid as pilots. So in the morning, again, you see that the land area looks pretty good. It's the coastal regions that we expect to have most of the convection here. But as we roll this through and watch what happens, by the time we get to around 14, 15, 16Z, now our particular route here down through St. Simon's Island is becoming problematic. That's where we're going to see all the way from Jacksonville, all the way up to maybe even as far north as Myrtle Beach and Charleston, South Carolina, where we're seeing that convection develop. And as you would expect, some of this is going to fill in pretty well throughout the day and into the early afternoon and even late afternoon, creating a hazard for us to basically work our way through there. It's not until we get to the kind of the evening hours when the sun goes down, so is the energy, and eventually we end up with, again, most of that convection happening along the coastal regions. So even this is possibly problematic for the early morning hours, for even the next day if we managed to get to somewhere in North Carolina and stayed overnight and got up the next morning. So this gives us that kind of indication. But the other product is a lot more it's a little bit easier product for most of us to kind of understand, and that is the forecast radar depiction, called it simulated reflectivity. Simulated reflectivity is a great tool because you interpret it just like you would a NEXRAD image. So if we roll this over to 11Z tomorrow, you can see that for the most part, up through Albany, New York, down through Martinsburg, West Virginia, and into the Carolinas, not much going on in terms of any kind of significant areas of precip. So again, you would kind of interpret this like you would a NEXRAD image. So the colors here are just reflectivity, the same as you would look at like a SiriusXM display in the cockpit and interpret it that way. But this is a forecast. So for tomorrow morning at 11Z, 12Z, 13Z, we're golden until we get to about the time around 15Z. Then we start to see some of that very scattered, isolated pulse-type thunderstorms develop. The coastal regions down in the parts of South Carolina and Georgia, and it becomes a lot more widespread in this area. Is this a complete no-go for some people? Sure, that would be a no-go for me personally, but ultimately for others that have, especially if you have any kind of onboard radar, you might be able to work your way through some of this convection. It will likely meet some convective sigmet criteria in this area, but you might be able to make it there by staying a little bit, maybe somewhere in maybe Charlotte area where I live, or maybe make it down to Columbia, South Carolina, or Florence. Wait it out. Maybe by the afternoon, evening hours when the sun starts to set, you might have a much better opportunity to get down here. But, again, you would have to wait and see how this all plays out, because ultimately this is telling us that we definitely have that convective potential, especially starting about noonish time frame all the way through somewhere on the order of, let's say, around 7 or 8 o'clock at night before things start to settle down a little bit in that area. So that gives us the perspective that we're looking for overall with this kind of system. So let's finish up here and let's look at one more product I like to look at from a standpoint of trying to understand all the different aspects of flying through this, is that we want to also look at the ceilings below 3,000 feet. So if you were making this trip VFR, for instance, and I do a lot of VFR flying in the summertime simply because I can control my altitude, my route pretty thoroughly here. This particular product, again, is a probabilistic forecast here. So we're looking at it from the standpoint of trying to understand what happens tomorrow morning. anywhere you see the reds and oranges, there's a high probability that the ceiling will be below 3,000 feet. So going to be difficult. So in the early morning hours here in the Carolinas at 11 and 12 Z or so, you notice that we do have a lot of areas where there's red, orange, and some blue. So there's a really good chance in those regions that you're not going to be able to fly through here easily VFR. Now you'd be able to fly on top potentially, but if you attempt to do that, you may be looking at a kind of an overcast kind of scenario. So ultimately that may be very difficult in the early morning hours. But as you would expect, as the heating of the day kicks in, and that those lower clouds tend to mix out. So by the time we get to 21, 22 Z, now we're showing just a bunch of kind of scattered green areas, which means it's a low probability that you're going to see ceilings below 3,000 feet in these particular areas. So that kind of gives us that perspective that the afternoon hours would certainly have a lot of convective potential in those areas, but maybe by later in the afternoon, early evening, that we might be able to continue that route all the way down to St. Simon's Island. But again, you have to be very careful. It's your fuel stop. Take a quick look at things and decide whether or not you're going to make the rest of the trip at this point in time. And for some looking at this may be a no-go from day one. And that's a good thing if you're making that decision. There's no problem with doing that because there's real value in what you see here and being able to make that decision without hesitation. But if you are, again, instrument weight rated pilot, you've got a lot of experience and time, you really feel comfortable with flying in convective scenario, you've got your SiriusXM on board, you're really trying hard to make sure you stay clear of anything significant, don't fly under anything that's intense or through it. You may be able to challenge some of this weather, depending, again, especially if you have any kind of onboard radar, this may be a very doable flight, especially in the higher flight levels. So again, this is a kind of a good approach to use to get that kind of big weather picture to know what's going on. And of course, you're going to look at terminal forecasts. You're going to look at the surface observations, pilot weather reports, and also when you wake up in the morning, look at all the advisories to kind of finally put all this together. But I do 95% of my pre-flight planning, about 95% of it, usually about this time for a trip tomorrow morning. And the goal, again, is to focus on that big weather picture, understand what's going on. Once I have that mentally in my head, I wake up the next morning. A lot of it's just fine tuning. Is the weather exactly the way I saw it the night before? If not, then maybe I need to do a little bit more digging. I'll pull a few SKUTs into the mix to try to figure out what's happening maybe at St. Simon's Island or what's happening maybe a little bit closer to as I make my way to my destination. So a lot of things kind of come in to fill in all those details. And certainly there's a lot more details that need to be filled in as you make your way forward here. Okay. All right, so last point here, and I try to make this point as much as possible throughout all my presentations. And that is, you see this kind of interesting looking accident here for this pickup truck that managed to somehow jump the guardrail here, and you think that's a pretty nasty accident there. The first responders are doing their job, but you really missed the big point here, and that is that all these details are quite important, but from the standpoint of as you look at the big picture here, you got to pan backwards, and the big picture is the king in terms of this kind of the stuff here. So it's important to keep that big picture in mind when you're making all those decisions about pre-flight planning. So, all right, so EZWxBrief.com, have a 14-day trial, no credit card needed to do a 14-day trial of EZWxBrief. There's my email address if you want to reach out to me, support@EZWxBrief.com. And there's my SKUT Log P and Me ebook. I'm doing pre-orders now. The book should be out by the beginning of AirVenture on July 25th. And there's the website where you can go pre-order it, avwxtraining.com/SKUT.